Namaste to all my dear students. Now I am telling you very important things. So what we see, sometimes I ask you write down the acidic order of the following compounds. Yes. So first one is effect of substituents on the strength of the acid. So first one is what you see, methanoic acid, ethanoic acid, and that is what you see, propanoic acid. Propanoic acid. So when talk, so in this case, yes, no any what you say electron donating or it's what you say electron pumping group over here. So that is more. What you see more with respect to ethanoic. Ethanoic, you know, in this case, methyl group is electron donating group. It increases the electron density over here. So it is less acidic with respect to methanoic acid. Next one, what is the ethyl group? So ethyl, due to presence of ethyl group, it has what's the lowest electron over there, more electron density over here. So it is more what we see, we can say less acidic with respect to ethanoic with respect to methanoic. So sometimes ask you this trend, sometimes ask you trend like this. So what you see, methanoic acid, this is the benzoic. So C6 what you see positive, that is the negative inductive effect, negative. Yes. So C6, what the nature of C6H5? It withdraws the electrons. What happens over here? So electron density is somewhat lower over here. So that is what you see less acidic with respect to methanoic. Why? In methanoic there is no any what you see alkyl group or phenyl group. This so C6H5 is phenyl group, that is known as phenyl, or we can say aryl group. And what the nature of this one? It withdraws electrons. So negative inductive effect over here, negative inductive effect. But when you talk about the ethanoic cases, what you see? CH3 is what you see electron donating group or pumping group. So that is what you see plus positive inductive effect. So it causes more electron density over here. So the bond in between O or H is what you see very strong with respect to benzoic acid and what you see methanoic acid. So this acid is very weak with respect to benzoic acid and methanoic acid. Yes. Next one is sometimes ask you write down the effect of electron withdrawing substituents. How many electron substituents? Suppose in this case 3 chlorine, all halo group are what is electron withdrawing group. So 3 chlorine group over here, so it withdraws the electron towards. So what we see over here, electron density is very low. If electron density is very low, it loses proton easily. So it is a stronger acid. But when you talk about the dichloro, in this case 2 chlorine with electron withdrawing group only. So in this also what you see, it withdraws the electron, no doubt. But in this case when you talk about the trichloro and what you see dichloro, in this case electron density is somewhat more. So the bond is somewhat stronger. So it loses what you see proton, no doubt. Why? Because it is acid. But in comparison to trichloro, what you see, it is less. It has high. Easily what you see loses proton. Somewhat difficult. But when you talk about this, in this case only 1 chlorine electron withdrawing group. So what you see, it causes less electron, what you see, it causes the electron density over here less. So what you see, the bond in between O and H is very strong. So it loses acid proton not so easily. Why? Because in this case bond is very strong with respect to dichloro and trichloro. So that trichloro is very stronger acid, that is weaker acid. That is stronger, that is the weakest in this case, weakest acid. That is what you see, strongest acid, that is in between. Now next one is effect of, sometimes ask you Write down the fact of what's the electronegativity value of electron withdrawing substituents. So always keep in mind, the elements which have more electronegativity, it withdraws the electron, what you see, quickly, and so the bond in between O and H is very less, very weak. So it loses proton easily. So that is the strongest state. Why? Because the electronegativity value of fluorine is 4. But when you talk about the trichloro, what you see, acetic acid or ethanoic acid, you can say. Ethanoic means IPAC system. Acetic acid, what you see, common name. So in this, chlorine has 3.0. So what you see, in this also it withdraws the electron, no doubt. But with respect to fluoro, what you see, it's somewhat less. So the bond in this case is somewhat stronger. So it loses proton, no doubt. But with respect to what's the fluoro, it loses somewhat difficulty. Likewise, when you talk about the bromine, so in this case, the electronegativity value of bromine is 2.8. Also, what you see, withdraws the electron towards itself. So in this case, what you see, 2.8. So a bond in between the O and H is somewhat stronger with respect to chloro. And what you see, fluoro, what you see, ethanoic acid or acetic acid, we can say. So in this, the electronegativity value of bromine is 2.8. In this case, the electronegativity value of iodine is very low, 2.4. It also withdraws the what you see, electron. But in this case, the bond is very strong. So it loses what you see, acidic proton, what you see, with difficulty. So that is weakest. That is the weakest, that is the strongest. Yes. So we have to explain. If you ask in examinations, we can explain, I think, nicely. So thank you for watching this video.